chemical properties of aldehydes and ketones. Chemical properties of aldehydes and ketones. See, aldehydes and ketones generally participate in nucleophilic addition reaction. Aldehydes and ketones generally participate in nucleophilic addition reaction. Their characteristic property is nucleophilic addition reaction. Okay, let us see what is a nucleophilic addition. This is aldehyde or ketone. Okay, this is nucleophile. Negatively charged species are called as nucleophiles, right? In carbonyl carbon, okay, group, carbonyl carbon group, carbon is having partial positive charge, oxygen is having negative, because oxygen is more electronegative, so it gets negative charge. Carbon is electropositive, means with respect to oxygen. Clear? So nucleophile adds to carbonyl carbon, right? At that time this bond will shifts onto oxygen atom. Okay, or HCO negative. Here you are adding nucleophile and R. Nucleophilic addition reaction. So the characteristic property of aldehyde or ketone is nucleophilic addition reaction, because in aldehyde and ketone carbonyl group is present. Okay, and carbonyl carbon is having positive, that will be attracted by the nucleophile, negatively charged nucleophile. Clear? Right. Now let us see aldehyde and ketone which is more reactive. Let us see aldehyde and ketone which is more reactive towards nucleophilic addition reaction. This is very important reactivity comparison. Okay, look at this. I am taking one aldehyde, CH3, C double bond OH, CH3, C double bond O, CH3. I am adding nucleophile to it. Nucleophiles are negatively charged species. They add to positively charged carbon. Clear? Right. Now I am writing positive charge on this carbon. See the magnitude, size of the positive charge. Here I am writing positive charge like this. See the magnitude. Positive charge is less. Positive charge is less. Here positive charge is more. Large positive, small positive, right? If larger is the positive charge, then nucleophile attacks easily, and rate will be more. Let us consider rate as R1. If positive charge is small, then attack of nucleophile is difficult. Clear? Let us consider reaction rate as R2. So what is the relation here? R1 is greater than R2. Means aldehydes readily react with nucleophile when compared with the ketones. Why? What is the reason for it? Why I wrote a large positive, bigger positive here, and why I wrote a smaller positive here? Clear? Right. Are you getting what I am explaining? Both of you. Okay. See, why I wrote large positive here and why I wrote small positive here? Why nucleophile attacks easily on aldehyde? Why not on the ketone? See, in this case we use GOC, General Organic Chemistry concept. Clear? You know methyl group. Methyl group is a electron donating group. Methyl group is a plus A group. So I'm writing it as a plus A group. Clear? And you know plus A groups donate electrons. Here also I'm writing plus A. This is one plus A, and here one plus A. Two plus A groups are present here. Two plus A groups are present, right? This side one plus A and this side one plus A. Two plus A groups are present. two plus I groups transfer electrons to positively charged carbonyl carbon and they neutralize the positive charge, they decrease the positive charge. Okay, this methyl is giving electrons and this methyl is giving electrons. From two sides electrons are coming, so in the middle positive charge is there now, that will neutralized. Clear? You know what happens if you give negative charge to positive charge density will decrease. Clear? So large positive will become small positive here because electrons are coming, electrons are neutralizing that positive charge, so in ketones, very very important, in ketones positive charge density is less on the carbonyl carbon. If positive charge is less, so attack of nucleophile is difficult, our rate is lesser. Clear? But in case of aldehyde, only one side plus I group is present. Only one side plus I group is present. This side plus I is not there. Plus I is not present. Clear? So compared to positive charge in the ketone, in the aldehydes positive charge density is more, magnitude is more. Large positive is present. If positive charge is large, then nucleophile attacks easily. Very 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 important reactivity comparison. Aldehydes are more reactive towards nucleophilic addition than ketones because in aldehydes positive charge is less, positive charge is more. In ketones positive charge is less. Clear? Positive charge, this is one reason. Another reason also we'll discuss. Clear? Okay, steric factor also, steric factor or bulkiness. If we consider methyl group as a bulky group, okay, two bulky groups are present, so attack of nucleophile will become difficult in terms of steric factors. Clear? In case of aldehyde, only one methyl is there, this side small hydrogen is there, so nucleophile will come easily. That is another reason. Clear? In terms of steric factors, in terms of positive charge and in terms of steric factors. Clear? You can follow one thing, right? Okay. Let us generalize this statement. Very very important. Under note I will give you aldehydes are more reactive. Aldehydes are more reactive than ketones towards nucleophilic addition reaction. Aldehydes are more reactive towards a nucleophilic addition reaction. What is the reason? Say the reason what I explained. Say the reason. Tell me the reason. Yes. In aldehydes only one plus I group is present. So large positive is present, large positive charge is present on carbonyl carbon. So attack of nucleophile is easy. Attack of nucleophile is easy and rate of reaction is more. Clear? Already I mentioned large positive and small positive. You can write if you want to write here large positive. You can write here small positive. Okay, right. Clear? Right. Okay. I am giving one important example. Okay. Compare the reactivity of following compounds. Compare the reactivity of following compounds towards nucleophilic addition. Towards a nucleophilic addition reaction. Towards nucleophilic addition reaction. First compound formaldehyde, second compound acetaldehyde, third compound acetone, and fourth compound acetophenone. Here names also very important. You should remember the names also. Sometimes you will get the names instead of structures. This is formaldehyde. IUPAC's name is methanol. Formaldehyde. This is acetaldehyde. Common names also very important. Acetaldehyde, and this is acetone, and this is acetophenone. Okay, let us see the reactivity order. Reactivity comparison. Clear? So according to our previous discussion, aldehydes and ketones, which are more reactive towards nucleophilic addition, obviously aldehydes only, because in aldehydes large positive charge is present. Let us take formaldehyde. H, double bond OH. See, I am writing positive charge magnitude here. Very large positive charge is present because there is no plus I group. And groups also very small. H. So the steric hindrance also very less. Okay. So formaldehyde is readily reactive towards nucleophilic addition. Large positive charge is present. Next, compare with acetaldehyde. Compare formaldehyde with acetaldehyde. In acetaldehyde, one plus I group is there. So positive charge is a little less, right? So I am decreasing the positive charge magnitude. See, large positive, some little small positive, right? In ketones, two plus I groups are present. So two sides electron donation is there. So I am decreasing positive charge further. Clear? Right? Very large positive, small positive. And in case of acetophenone, you know, benzene ring pi electrons will be transferred, and the positive charge is almost nullified. Very small positive due to resonance. So in acetophenone, positive charge is very small, so there is no chance for the attack of nucleophile, or reactivity is very less. Now can you give the reactivity order now? Which is more reactive? First, which will come first? Formaldehyde. One greater than 2. Acetaldehyde. After that, acetone. Last one, acetophenone. A very important question. Got it? No doubt. So what is the key step here? If positive charge is more, then reactivity is more. If positive charge is more, then reactivity is more. Clear? No doubt in this, right? Okay. Next, another question. Which of the following is more reactive towards nucleophilic addition? Which of the following is more reactive towards nucleophilic addition? Can you guess which is more reactive towards nucleophilic addition? Which is more reactive? Last one. Why? Why? Because two minus m groups are present. See what happens if minus m group is present. See, if minus m group is present, it withdraws electrons and making more positive charge. This carbonyl carbon is having positive, large positive. So here I have. Okay, compared to carbonyl carbon of this and this, because minus m group is there, NO2 is a minus m, electron withdrawing. If it withdraws electrons from the aldehydic carbon, then aldehydic carbon will get positive charge. Clear? Similarly, in the last case, in option D, two minus m groups are present. So here more positive charge. Okay, positive and more positive. So nucleophile will attack easily on last aldehyde. Clear? If more is the positive charge, then more will be the reactivity. This is based on the minus m concept. Clear? Heading first nucleophilic addition reaction. Addition of HCN. Addition of HCN, hydrogen cyanide. Addition of hydrogen cyanide. This is nucleophilic addition only. How HCN will dissociate? HCN dissociates into H plus plus Cl negative. Okay, right. I am taking aldehyde and adding HCN. Now you tell me, carbon is having which charge? Positive charge. Oxygen is having which charge? Negative charge. So positively charged hydrogen attaches to oxygen and negatively charged Cn minus attaches to carbonyl carbon to give a compound which is called as cyanohydrin. What is its name? Cyanohydrin. The compounds in which one carbon attaches to cyanide and OH, that is called as cyanohydrin. And very, very important point, look at this carbon. This is chiral carbon, right? It is surrounded by how many atoms or groups? 4 different atoms. So this is chiral. So optically active. The formed compound is optically active. Very, very important. Which of the following reaction produce optically active compound? Clear? Common name of the product is cyanohydrin. Let us see another reaction. Now, guess here what is the product? right? Correct or no? This is also cyanohydrin. This is also cyanohydrin. Is it optically active? Is it optically active? Tell me. Why? This carbon is not surrounded by 4 different groups. So this is not optically active. Not optically